In this video, we are going to discuss a few questions on diffusion. Let's look at the first question. Which statements about diffusion are correct? Aqueous ions cannot diffuse in water. That is wrong. Aqueous ions can diffuse in water. Diffusion is caused by the random movement of particles. That's right. Particles spread out in all directions in diffusion. Again, right. Diffusion can only take place in solids and liquids, which is wrong. It's also possible in gaseous stage. So it's 2 and 3. The answer is C. Which statement explains why ammonia gas diffuses at a faster rate than hydrogen chloride gas? So there are two things that affects diffusion. One is temperature. Here temperature is not mentioned, so we assume it's happening at the same temperature. The second one is the mass, the relative molecular mass of the gases that we are comparing. So here there are two gases that we need to look into. NH3, it has a mass of 17 gram per mole, or let's say 17 grams, and HCl has a mass of 36.5 grams. So ammonia expands to occupy all of the space available. No, all gases do that. Ammonia has a smaller relative molecular mass than hydrogen chloride, which is actually correct. Ammonia has a smaller relative molecular mass because ammonia is 17 and HCl is 36.5. Ammonia is an alkali and hydrogen chloride is an acid. It doesn't matter. Ammonia molecule diffuse in all directions at the same time. That's not a comparison. Hydrogen chloride gas is released at P in the apparatus zone, so it diffuses towards the universal indicator paper. So the universal indicator paper turns red after 38 seconds. Now the experiment is repeated using sulfur dioxide, which has a higher mass, so we expect this to happen a bit slower. It's going to take longer time because it has a higher mass, right? Now, what is the result for sulfur dioxide? So sulfur dioxide being an acid, sulfur is a non-metal, so sulfur dioxide should be an acid, right? It's going to turn universal indicator paper red, not blue. It should be red, right? So you look at 26 seconds. Something that has a mass of 35.6 took 38 seconds. So another gas that has a higher mass should take a longer time. So it should be 51. The rate of diffusion of a gas depends on its molecular mass and the temperature. Which combination of molecular mass and temperature gives the slowest rate of diffusion? Slowest rate of diffusion. So if you look at the molecular mass, higher the mass, slower the diffusion. So it should be high for a slow diffusion. And temperature for a slow diffusion should be low. So B is the answer. Which two gases will diffuse at the same rate at the same temperature? So the only thing that we are looking at is those two gases should have the same molecular mass. So carbon monoxide has a molecular mass of 28 and carbon dioxide has a molecular mass of 44, so definitely not an option. Carbon monoxide is again 28. Nitrogen, so nitrogen being a diatomic gas, right? So whenever you have been given such a question, you will always have to go for their atomicity, if they are diatomic or monoatomic, right? All gens are diatomic. So when I say all gens are diatomic, it's nitrogen, oxygen, hydrogen, and all the halogens. All of them are diatomic. So the mass of nitrogen is 28. That's the answer. Chlorine and fluorine definitely have different masses. Nitrogen and oxygen has different masses. They also have different masses. The formula of methane is CH4 which has a mass of 16, and the formula of ethane is C2H6 that has a mass of 30. Which row describes diffusion and the relative rates of diffusion of methane and ethane? So let's look at this one first. Ethane diffuses more quickly. No, it cannot. It has a higher mass. Methane diffuses more quickly. Yes. Yes. Now, particles move from a low concentration to a higher concentration. That's not the definition of diffusion. Diffusion is when particles move from a higher concentration to a region of lower concentration. B is the answer. Which gas has the slowest rate of diffusion? So it should have the highest mass. Carbon dioxide has a mass of 44, CH4 has a mass of 16, NH3 has a mass of 17, and H2 has a mass of 2. So it has to be the one that has the highest mass, highest relative molecular mass, and that's D. A gas is released at point P in the apparatus shown. Which gas turns the damped universal indicator paper red? So it has to be an acidic gas. So let's rule out the alkaline or basic gases. So not this one and not this one. Now it's either hydrogen chloride or sulfur dioxide. So it has a mass of 36.5 and sulfur dioxide has a mass of 64. So the one that moves quickly is going to be HCl. Brownian motion and the diffusion of gases provide evidence for the particulate nature of matter. Which row identifies an example of Brownian motion and how molecular mass determines the rate of diffusion of gas molecules? So Brownian motion, pollen grains in water are seen to move randomly, right? The dissolution has nothing to do with it. Heavier gas molecules diffuse more quickly. No, the lighter ones does that. The lighter gas molecules diffuse more quickly is right, and B is the answer. The diagram shows the result of dropping a purple crystal into water. Which processes take place in this experiment? Definitely this crystal dissolves, so there is dissolution, right? Now there's also diffusion, otherwise there should be two colors for the solution, but it mentioned purple solution, right? So there is diffusion and dissolving, so the answer is D. And there will not be any chemical reaction because there is no mention of a new substance being produced or any other indication of a chemical reaction. Samples of 4 gases are released in a room at the same time. The gases are carbon dioxide, hydrogen chloride, hydrogen sulfide, and nitrogen dioxide. Which gas diffuses the fastest? The lightest one. So we need to look into the mass of all these. CO2 has a mass of 44. Hydrogen chloride has a mass of 36.5. Hydrogen sulfide has a mass of 34. And nitrogen dioxide has a mass of 46. So it has to be the one that's the lightest, H2S.